Okay, so for this class, we are going to talk about Chapter 11, Annuities, Stocks, and Bonds. Annuities and retirement accounts, that's for section 11.1. Our objectives are to define the basic terms involved with annuities, find the amount of an annuity, find the amount of an annuity due, and understand different retirement accounts. So an annuity is a series of equal payments made at regular intervals. Ordinary annuity are payments made at the end of each period. A payment period is the time between payments, and the term of the annuity, time needed for all payments to be made. So whenever you hear about your grandparents or, for my case now, my parents talking about retirement, and they're living off of pensions and stuff like that, all of that is a type of annuity. Annuity compound amount or future value of the annuity is the total amount in an annuity on a future date. So to find the amount of an annuity, you're going to take the payment times the number from the amount of an annuity table. And we're going to see that in a minute. Okay, so it's too hard to see on the screen. You can either do a screenshot and zoom in. You can also find this in your textbook. Okay, so let's look at an example. Darnell Johnson's employer contributes 4% of Darnell's $38,400 salary into his retirement plan. Additionally, the hospital matches the 1% of his salary that Darnell himself puts into his own plan. Find the future value in 10 years, assuming that A, funds earn 5% compounded semi-annually, and B, funds earn 8% compounded semi-annually. Then find the difference between the two. Hint, assume all contributions into the plan occur at the end of the semi-annual periods. All right. Okay, so here's the first option. We have salary per quarter. So he's dividing his quarter up, or his salary up. Total contributions are Darnell plus the employer. So then the total going in is the 1,152 every 6 months. So at 5%, we're going to divide that by 2 because it's semi-annually, so 2.5% per 6 months. And then it's for 26-month periods. So you would go into the table. So here's 20, and that's probably the 2.5 column. All right, so from the table, you get this, and then you're going to multiply it by the amount that we found. Okay, so it would be 29,427.45 cents, the answer for part A. Part B is going to be extremely similar. Okay, you'll do 8% divided by 4 is going to give you 2% per 6 months for 20 periods. I don't know why they're dividing by 4 here. I feel like they should be dividing by 2. Give me a second. Yeah, I feel like they definitely should be dividing by 2. Just like they did here. So there's a chance this could either be messed up or you would have to check that with the table. But anytime it's semi-annual, that's 2, so you should divide it by 2. If they divided it by 4, they would be dealing with a quarter. Okay, so if you want a chance for some extra credit on your minor quiz for chapter 11, then rework this problem as if you were doing it per semi-annual and not per quarter, which is what I feel like they're doing here. So I'm not even going to go over this information. Okay. All right. Find the amount of an annuity due. An annuity in which payments are made at the beginning of each time period is called an annuity due. So step 1, add 1 to the number of periods. So step 2 then is payment times the number from the amount of an annuity table. And step 3 is subtract 1 payment. So here's this example. Hopefully it'll be correct. Mr. and Mrs. Thompson set up an investment program using an annuity due with payments of $500 at the beginning of each quarter. Find A, the amount of the annuity, and B, the interest if they make payments for 7 years into an investment account expected to pay 8% compounded quarterly. So now we can divide by 4. See? I knew we knew what we were talking about. So this says step 1, do 4 times 7, which equals 28 periods, and add 1, so 29 periods. And then we're going to do interest. 8% divided by 4 gives us 2% for each quarter. So from the table, we get this amount. So the number from the table might have been right in that last problem, but they definitely divided wrong. All right. And then step 3, you're supposed to take away a payment. I don't know why they're adding a period and then taking away a payment like that. To me, why don't they just figure out the 28 and be done with it? But maybe that would give them the wrong amount. All right, subtract the 28 payments of $500 each to find the interest. And the interest is $4,896.12. All right. Understand different retirement accounts and find the amount of a retirement account. So IRA is individual retirement account. Regular IRA deposits are usually tax deductible and grow income tax free. Funds are subject to income tax when withdrawn. So I don't know about you guys, but I don't know. I know I'm older than you guys, but I still don't even think about my retirement, and I know that upsets my parents a lot. I think I just kind of feel like my job is so much fun that I'm probably just going to do it until I die anyway, so why do I have to worry about retirement? But and it's kind of super easy, so I don't know. But if I was going to do a retirement setup, I would definitely want it to just be kind of like my regular insurance. So this one is regular bank account. So this one says Roth IRA. Deposits are not tax deductible but grow income tax free, and funds are not subject to income tax when withdrawn. So that's the one I would want to do, because I would rather pay on the taxes while I'm making money, and then when I don't have any money coming in, when I take the money out, I wouldn't want to pay on it. That's just me. All right. At 27, Joanne Gretz sets up an IRA with online broker Charles Schwab, where she plans to deposit $2,000 at the end of each year until age 60. Find the amount of the annuity if she invests in either A, a bond fund that has historically yielded 6% compounded annually, versus B, a stock fund that has historically yielded 10% compounded annually. Assume that the future yields equal historical yields. So age 60 is 60 minus 27, which is 33 years away. Make deposits at the end of each year for 33 years. Bond A. Kind of like James Bond. So, but we don't have Bond J. We have Bond A and Bond B. From the table, column 6%, row 33, we find this amount. So then amount is going to equal 2,000 times the 97 point blah, blah, blah. So you get 194,686 and 32 cents. So from bond B, or stock fund, I guess, from the table 10% and 33, we find 222 and 25,154. Multiply it and you get $444,503.08. The difference in the two investments are shown in the figure on the next slide. Gretz wants the larger amount, but she is worried she might lose money in the stock fund. So here's our difference. You can see for a while, she's not going to see a large return. And then when she starts to hit like 30, 38, 39, she sees some small separation. And then by the time she's like 45, you see bigger and bigger and bigger until when she gets to 60, that's a huge gap, but it also comes with a risk. So you have to always consider that too. Okay, we're going to continue with section 11.2, present value of an ordinary annuity. We're going to define the present value of an ordinary annuity, use the formula to find the present value of an ordinary annuity, and find the equivalent cash price of an ordinary annuity. So present value of annuity can be thought of in two ways. Annuity that accumulates funds, or an annuity that uses up funds that may have already been accumulated to make a series of payments. All right, a single lump sum deposit that results in the same future value as making regular payments for a specific amount of time. For example, say a firm needs $100,000 in 5 years. It can achieve that goal either by making a single lump sum deposit, the present value, or making regular payments. So if you go back to that first example, that's, an example of payments. The lump sum needed today to fund all regular future payments that need to be made. For example, a judge requires a divorced man to make $1,500 child support payment at the end of each quarter until his son turns 18. This can be achieved by depositing a large lump sum today, the present value, that will generate the necessary payments. See example 2. So we're going to go through both of those. Whoop. Finding present value of an annuity. Present value of an annuity is equal to the payment times the number from the present value of an annuity table. If I've not said it once, I've probably said it 10 times at this point. I highly recommend you print these tables out. I have them all printed. It really saved me during the homework to just have them printed and not have to use the little tiny one on the computer. That ends up, I think, getting kind of confusing when you look at it, and then you end up making silly mistakes. Whereas if you can just kind of have it printed out and either use a highlighter or, if you just want to use a pencil or even just your fingers and go down and across, it's a lot better than trying to do it on the computer, I think. All right, take a minute and read example 1. Okay, we have the daily news plans to accumulate funds ahead of time to purchase a computer network. It deposits $4,325 into an account at the end of each quarter for 5 years. The account pays 6% compounded quarterly. Find the lump sum that must be deposited today to accumulate the funds needed, the present value. Use the concepts of section 11.1 to find the future value of the annuity. So again, you can see they're giving you a diagram here. I will tell you that because I did the homework way before I went over this lecture slides with you, I did not use any diagrams. But again, as I've said in the past, if the diagrams help you out, then please do them. Okay, so this is saying large lump sum today. You could just pay that off and be done. And it needs to be by the end of 20 payments, you need to have the grand total. All right. So this is saying interest is 6% divided by 4 is going to be 1.5% per quarter for 20 quarters. From the table, use 1.5% in 20 periods and find 17.16864. So the present value is going to be $74,254.37. To find the future value, use the amount of the annuity table with a payment of $4,325 for 20 periods, and section 11.1 to find 23.12367. So the future payments would be $100,009.87. The future value of $100,009.87 can be achieved with a large lump sum deposit of $74,254.37 today, or by making 20 end of the quarter payments of $4,325 into a fund. In both cases, we assume funds grow at 6% compounded quarterly. I don't know about you guys, but I definitely could not afford that. So more power to whoever's doing this. Oh, it was a computer company, right? So I guess a company could afford that. All right, let's look at example 2. Tish Baker plans to retire from nursing at age 65 and hopes to withdraw $25,000 per year until she is 90. If money earns 8% per year compounded annually, how much will she need at age 65? If she deposits $2,000 per year into her retirement plan beginning at age 32, and if the retirement plan earns 8% per year compounded annually, will her retirement account have enough for her to meet her goals? Find the present value of the annuity of $25,000 per year for 25 years at 8% compounded annually. So you use the table and you get $266,869.50 after you multiply. So Baker will need that large lump sum at the age of 65. This sum at 8% compounded annually will permit withdrawals of $25,000 per year until the age of 90. So payments of $2,000 at the end of each year for 33 years at 8% compounded annually, then we're looking at $291,901.24. She will have enough since the $291,901.24 exceeds the needed $266,000. She is unlikely to earn the 8% at a bank. She will need to invest in stocks and bonds. Okay. Find the equivalent cash price of an ordinary annuity. So that means the present value that is equivalent to a payment or series of payments. Best way to compare investments is by comparing equivalent cash prices. So let's look at our next example. Gene Braddock offers some land to 2 different real estate developers. Captain Homes offers $200,000 in cash today for the land. Real Property offers $80,000 now as a down payment and payments of $10,000 at the end of each quarter for 4 years. Assume that the money can be invested at 8% per year compounded quarterly, which is the best offer. So obviously, since the first one is $200,000 now, then you would take 8% divided by 4, and then that's going to be for 16 periods. So we take the table amount times the 200,000, or I guess subtracted. This is to help us do the other one though. Okay. Yeah, that's what I thought. The 200,000 is left alone. So then we do that to figure out how much the other value was worth. And definitely don't just go into the homework and go, oh, it's always going to be this one, because it doesn't end up being the case. Sometimes the money up front is worth more, but it just so happens for this case. And I mean, I would have the same thought. I did have the same thought for one of the homework problems. I was like, oh, well, it's obviously going to be the second option. It is not always the second option. Still work it out. and you will be able to see that sometimes the cash price is worth more than the other option they're willing to give you.